Hello students, welcome to experiencetutor.com. Today we'll go through the lesson Electrostatic Part 4. Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th. And those who are appearing for the school board examinations and entrance examinations like IIT, NEET, and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you. Question number 27. Explain the term line or linear charge density, surface charge density, and volume charge density. Line or linear charge density lambda if the charge is distributed over a straight line or over the circumference of a circle or over the edge of a cuboid, etc., then distribution is called linear charge distribution. Linear charge density is the charge per unit length. Its SI unit is coulomb per meter. Lambda is equal to Q by L or lambda is equal to delta Q by delta L. Total charge on a line L is equal to L. Q is equal to integration of lambda dl. Surface charge density sigma. If the charge is distributed over a surface, then the distribution is called surface charge distribution. Surface charge density is the charge per unit area. Its SI unit is coulomb per meter square. Sigma is equal to Q by S or sigma is equal to delta Q by delta S. Total charge on surface S. Q is equal to integration of sigma ds. Volume charge density rho. If the charge is distributed over a volume, then the distribution is called volume charge distribution. Volume charge density is the charge per unit volume. Its SI unit is coulomb per meter cube. Rho is equal to Q by tau or sigma is equal to Q by tau. Rho is equal to Q by tau. Rho is equal to delta Q by delta tau. Total charge on volume tau is equal to tau. Q is equal to integration of rho d tau. Question 28. Explain electric field. A charge produced some effect in the space around it. The region around the charge in which the effect of electric charge is prevailing is called the electric field of the charge. This electric field can interact with other charge Q0 placed in it and extract the force on it. It does not extract the force which produces the electric field. Thus, electric field acts as an agency between Q and Q0. Suppose a charge Q is placed the origin at an origin of a coordinate system. Now bring a charge Q0 at the given point in the electric field without disturbing the position of the charge capital Q. If the position vector of the point is vector r, then electric field at that point can be defined as follows. E vector r is equal to F vector r upon Q naught. Here E is called the electric field or electric field intensity of charge Q at a position vector r. The quantity E is independent of Q. It is dependent solely on the magnitude of the electric charge of the system, their arrangement, and the position vector r for Q naught. The charge Q naught used to define or to measure intensity of the electric field is called a test charge. The charges producing electric field are called source charges. The SI system In SI system, the unit of electric field is Newton per coulomb or V per meter. V per meter. V is the potential difference. Electric field is a vector quantity and it is the direction of force acting on unit positive charge at a given point. If system of charges consist of more than one charge, then electric field at a given point can be obtained by using Coulomb's law and superposition principle. Question 29. Explain superposition principle of electric fields. Consider a system of charge Q1, Q2, Qn with position vector R1, R2, Rn relative to origin. The electric field is produced in the region surrounding the system due to the system of charges. We want to determine the electric field at a point P, X, Y, Z having a position vector r. For this purpose, place a very small test charge Q0 at the point and use the superposition principle. Electric field at point P due to charge Q1 is given by E1 is equal to F1 upon Q0 is equal to K Q1 upon modulus of R minus R1 cube multiplied by vector R minus R1. Electric field at point P due to charge Q2 is E2 is equal to F2 upon Q0 K Q2 upon modulus of R minus R2 square r minus r2 cube multiplied by r minus r2 vector. Same way, electric field at point P due to charge Qn is En is equal to Fn upon Q naught is equal to K Qn upon modulus of R minus Rn to the power Q multiplied by vector R minus vector Rn. According to the superposition principle, net electric field at a point P is E is equal to E1 plus E2 plus E3 En. Now putting the values of E1, E2, E and En, we will get K Q1 upon modulus of R minus R1 to the power Q multiplied by R minus R1 plus K Q2 by R minus R2 modulus of modulus to the power Q R minus R2 plus plus K Qn upon modulus of R minus Rn to the power Q multiplied by R minus Rn. E we can write as K sigma I is equal to 1 to n Q I upon R modulus of R minus R Rz to the power Q into R vector R minus Rj. Here Q1, Q2 Qn are the source of electric field. Note: first, to determine the electric field, there should not be any charge in the original system of charges due to the presence of a test charge. So, it is necessary that the test charge should be very small. To define electric field more precisely, Q0 tends to 0, but minimum value of Q0 is 1.6 into 10 to the power minus 19 coulomb. 2. Equation 1.5.2 indicates the force acting on the unit positive charge at point R, X, Y, Z. Once ER is known, we do not have to worry about the source of electric field. In this sense, the electric field itself is a special representation of the system of charges producing electric field as far as the effect on other charges is considered. Once such a representation is done, the force acting on charge Q kept at that point in the field can be determined using following equation: F R is equal to Q E vector R. Third point, the direction of force acting on unit positive charge at a given point is the direction of the electric field at that point. Fourth, Faraday was the first person to introduce the concept of electric field. Electric field is not an imaginary concept but a physical reality. Question number 30. Derive an expression for the electric field due to a point charge. As shown in the figure, consider a point charge q on the origin of a Cartesian coordinate system. In order to calculate electric field due to charge q, consider a test charge q0 at the distance r from the charge q. Force acting on charge q due to charge capital Q is F is equal to K q naught upon r square unit vector r. Therefore, electric field intensity at r due to q will be is equal to F by q naught is equal to K capital Q upon r square multiplied by unit vector r. The below figure shows the electric field due to the point charge in two dimensions using field vectors. From the figure, it is clear that for positive charge q is greater than 0, direction of field vectors are radially outward, while those of negative charge q is less than 0, the radially inward. The length of the arrow decreases indicates the decreasing the strength of the electric field and as we go away from the charge. Question number 31. Define an electric dipole. Derive an expression for electric field at a point on the axis of a dipole. A system of two equal and opposite charges separated by an infinite distance is called a dipole. As shown in the figure, the two electric charge of electric dipole are plus q and minus q, and distance between them is 2a. Electric dipole moment P of a system can be defined as P is equal to Q 2a. The SI unit of electric dipole is coulomb meter, cm. Electric dipole is a vector quantity and its direction is from the negative charge minus q to positive charge plus q. The net electric charge on an electric dipole is 0, but electric field is not 0 since the position of the two charges is different. If limit q tends to infinity and 2a tends to 0 in P is equal to 2aq, then electric dipole is called point dipole.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.